Alright, Mom, so tonight I'm going to teach you about protein synthesis. Okay, so the goal, it's made of two different parts, transcription and translation. The goal of transcription, the first step, is to create mRNA from DNA. So that's made because DNA, sorry, this is a pretty bad drawing. These are the different base pairs I was telling you about earlier. A to T and C to G. It separates, it unwinds. So a complementary mRNA copy can be made from that. And the mRNA copy that's made from the DNA has bases that are complementary to it, except for instead of A to T, mRNA has U instead of T. So if it said, for example, A, T, C, A, G, the complementary RNA would be U, A, G, U, C. Like so. And the entire process takes place in the nucleus of the cell. And the areas that are copied are exons, and the areas that aren't coded are introns. That's the first step of protein synthesis. Now let's get to the next part, which is translation. So the mRNA that we made from transcription is then travels to a ribosome, where the ribosome is also made out of ribosomal RNA, which is rRNA. And so the mRNA passes through the cytoplasm to get there, because to get from the nucleus to the ribosome, you have to obviously go through the cytoplasm. tRNA shows up at the ribosome with amino acids and anticodons. Okay, so say this is the mRNA chain. U, A, G, A, C, G, T, G, U, G. No, there can't be a T. These three parts are codons, these groups of three. The tRNA shows up with anticodons that are complementary to these, and it also shows up with amino acids. So it matches up the anticodons to the different codons, and then from there, the amino acids to the anticodons. So yeah, the tRNA drops an amino acid where it's supposed to be, and the amino acids are held together by peptide bonds. And at the very end, once you have all these amino acids, like for example, let's say for example, the chain is leucine, glutamic acid. This would be part of your protein, but of course it'd be a lot longer. And and sometimes there can be mistakes in the gene structure. Like for example, there could be a mistake when changing DNA to mRNA, and if there's a mistake in the part that controls the hemoglobin protein, sickle cell disease can occur, because then the tRNA codes for a different amino acid, and then in turn causes a different protein.